and also will determine the CMC, that is critical micelle concentration. अच्छा एक सेकेंड जस्ट वेट, इसको ना CMC को मैं इसका फुल फॉर्म लिख लेती हूँ. The slide is still there, right?
Yes, ma'am.
लिख लीजिए आप लोग एम. If we are done with this experiment today, so we won't be left with much more experiment. The only experiment which will be left will be some 2-3 experiments related to pH metry. Okay. So 3 experiments on viscosity we have done, 2 on surface tension we have done. These are only experiments which are there in your syllabus related to these 2 topics, right? pH metry mein I think you have to perform around 3 experiments. So that's it for semester 1. If you were in if you would have been in actual labs, what we actually do is, in the last experiment we have done a determination of surface tension of any unknown liquid, right? So what we actually do as practice in actual labs is we spend around 2 or 3 weeks in that experiment only by giving, today I've given you one alcohol solution, in the next class I may give you another like sucrose solution. So we keep on changing the solutions so that you can have an actual, you can have a practice, so that you can feel comfortable about the instruments you are handling, the class where you're handling. But यहाँ पे तो on things are moving faster here. Hello, is my voice breaking? It's now again showing bad network quality.
No, ma'am.
Hello?
No, ma'am, it's
Ma'am,
perfect.
you're audible.
So this is one of the demerits of this online mode. You're not able to see how a chemistry lab actually looks like. You're visualizing everything. You're just imagining everything, like how does a stalagmometer look like? How does an Ostwald viscometer look like? So you are not actually having the feel of how you actually perform a hands-on experiment. Koini, let's see. We are hoping for the best. Maybe in 1 or 2, 3 months the college may open. So from the next semester you may be able to do the experiments in the real labs, right? So लिख लिया आप लोगों ने aim of today's experiment?
Yes, ma'am.
Yes, ma'am.
Okay. So
Yes, ma'am.
in the last class we determined, we have an idea about how to अगर आप लोगों को एक unknown solution दिया गया तो उस unknown solution का surface tension हम कैसे निकालेंगे, right? So now today's experiment is a little bit of extension or a little bit of application on surface tension, कि how surface tension can be applied to other experiments also, like, right? So is experiment में you will be provided with different concentrations of detergent solutions. ठीक है, उसके बाद हम आएंगे detergent क्यों ले रहे हैं, why we are focusing on detergent solutions, और उसके बाद हम एक property निकालेंगे उसमें से which is known as the critical micelle concentration. So all of you must be having enough idea about it, but still let's have a brief idea about what actually detergent is and what is the role of detergent in surface tension and all, right? So first thing, there are some substances which are known as surface active substances, and in short they are also known as surfactants also, right? So what are these substances? These substances have a tendency to be, whenever you add, for example, you have taken some water in a beaker, right? उसमें आपने कुछ surfactants add किया, ठीक है? Surfactants मतलब surface active substance. हम इन substances को surface active substances इसलिए बोलते हैं क्योंकि जब हम उसको add करेंगे उस solvent में, water में या कोई भी solvent में, तो they will not be present in the bulk of the solution. They have a tendency to be present, to be floating on the surface, to be present on the surface of the fluid or liquid. So that's why we call them surface active substances. ठीक है? Is it clear बच्चे surfactants का definition? And present on the surface, they play a very great role in affecting the surface tension of that particular solvent, right? Hello, is my voice clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And they see and what will be the effect? What will the effect of the presence of these on the surface is, as all of you are aware, surface tension is a property, is a surface phenomenon. And surface tension in a fluid arises because of the surface molecules present on the in the liquid, right? The origin I explained in the last class, in a fluid or liquid, the molecules can be of two types. First is called the bulk molecule, which doesn't experience any net force, which moves as if it is independent of any other surrounding molecule, right? The second type is surface molecule, or surface molecule may, it is surrounded by two types of molecule. One is the molecules like molecules which are in the inward position. The other are the air molecules. Okay, and due to unbalanced force of interaction between two like molecules and the molecules on the above, that is the gas molecules, the surface molecule always has to be pulled inwards, and this is the real actual reason of origin of surface tension in a fluid, right? So if present, which will be present at the surface, then what? Then those surface molecules will be replaced by the molecules which are the newly added molecules. That is the surface, that those are known as the surfactants, right? So since they are replacing the liquid molecules which are on the surface, they will reduce the surface tension of the liquid. ठीक है बच्चे? Is this clear? Effect of surface surfactants on the surface tension of a liquid. Why they reduce the surface tension? Clear?
मैम एक बार और समझा दीजिए.
जब हम सर्फेक्टेंट्स को ऐड करेंगे तो दे विल रिप्लेस द सरफेस मॉलिक्यूल्स. ठीक है, द लिक्विड मॉलिक्यूल जो सरफेस में था उन सबको मतलब एक रिप्लेस कर देंगे. So what will be its effect is the surface tension arises in a fluid due to the presence of those surface molecules, right? अगर उसी surface molecules को हम दूसरे molecule से replace will be decreased, right? Because the force of interaction between the new added surfactants and the already existing liquid molecules will be very less. So इसलिए net inward pull जो है वो भी कम होगा. So that's why surface tension will be reduced, and even the addition of a small amount of surfactant reduces the surface tension to a very large extent. ठीक है? So this is a very peculiar unique property of surfactants. Examples are like soap. As all of you know, soap is used for cleaning clothes, right? This is one of the surfactants. Salts of higher sulfonic acids and of higher amines. So these are some the manufacture of detergents.
You are not audible.
No, एक second. Hello? Hello?
Yes, ma'am.
Is it okay now?
Yes, ma'am.
जो next line में लिखा है ना, these are some typical examples of surfactants, and these surfactants are used
मैम आपने
एक और
स्लाइड
चीज
चेंज
यहाँ
की है क्या?
कि this second slide ही है, we are still on the second slide.
मैम फर्स्ट स्लाइड ही शो हो रही है.
Senses. All of you, can you see the second slide जहाँ पे मैंने surfactants की definition लिखी है?
नो मैम.
No,
No,
ma'am.
ma'am. Your voice is breaking in between.
Now we can see the second slide.
Okay. Now you can see.
Yes, ma'am.
Just write a
Yes,
definition
ma'am.
of surfactants or surface active substances. Examples. All of you have written. और एक चीज और मैंने मेंशन किया है देखो वैसे when Sanjay Batra sir will be teaching you liquid state, he will be explaining to you in detail like formula and all, right? So I'll just explain to you verbally what actually is interfacial tension, right? So have you heard about interfacial tension? Bachche, can you hear me? Do you have any idea about
Yes, ma'am.
interfacial tension? हाँ जी. Anybody? Interfacial tension. आप लोगों का लिक्विड स्टेट स्टार्ट हो गया क्या? So in the other class. Hello. Hello.
No, ma'am.
Okay. अभी भी अनइक्विलिब्रियम पे ही हो अभी ना. तो आप लोगों ने सुना हुआ है ये टर्म इंटरफेशियल टेंशन? Which sounds
Yes,
very
ma'am. आपने
similar.
हैंडआउट्स प्रोवाइड किए थे, उसमें था ये टर्म.
Okay. ठीक है. So what do you mean by this? Apart from their handouts, have you heard of it before in school? That was what actually I was asking. Anybody in the class? कौन है आपके क्लास में? चंदर, this is a very frequent name. Chandar, Pratham, who else there? Shikha is there.
Yes, ma'am.
Do you have any idea about interfacial tension? How is it
No,
different from
ma'am.
surface tension?
No, ma'am.
No, ma'am.
चलो ठीक है. सरफेस टेंशन में इंटरफेशियल टेंशन जो है इज अ कॉमन टर्म एंड सरफेस टेंशन इज स्पेसिफिकली व्हेन सपोज आपके पास एक लिक्विड है एक बीकर में कंटेनर में, ठीक है? तो वन साइड में यू हैव द लिक्विड, ऑन अनदर साइड यू हैव गैस, ठीक है? सो टेंशन जो है दैट अराइजेस इन द फ्लूइड इज that is called surface tension when the other part is when you have gas on the other side. Is this okay? यहाँ पर you have one liquid only, one side is liquid, on other side of the liquid is the gaseous phase, ठीक है? So that kind of surface tension that develops on the surface is known as surface tension when you have gas on the other side, right? But there can be a case also when you have two immiscible liquids. Suppose you have mixed water and oil, right? So in that case you have water on one side and oil on the other side. So उसकी वजह से जो surface tension develop होगी on the surface of either on oil or on the surface of water, that is known as a interfacial tension, or on the interface of the two liquids, this is known as the interfacial tension. Is it okay? Do I need to elaborate more? Shall I explain more on this interfacial tension? आप लोग respond करो a little bit faster. बच्चे, are you clear about interfacial tension or not?
Yes, ma'am. It's clear, ma'am. Yes, ma'am.
Is it clear? So can anybody explain to me how does it work? Interfacial tension का origin, जैसे मैंने surface tension की origin बताई थी last class में, because of the bulk molecules and the surface molecule. यहाँ पर बता सकते हो interfacial tension, how will it work? If you're clear about it. हाँ जी बोलो, anybody can say. इंटरफेशियल टेंशन छोड़ो, सरफेस टेंशन के बारे में बताओ. व्हाट इज द ओरिजिन ऑफ सरफेस टेंशन? उसके बाद में I'll to it in order to explain interfacial tension. Anybody explain to me what is the origin of surface tension?
May I?
Yes, yes.
Ma'am, so there are the ma'am two type of the
What
molecules.
is
First, lying in the bulk, and
name?
second,
Hello,
surface molecules.
hello. Just keep a pause. What is your
Ma'am
name?
Vishakha, ma'am.
विशाखा. जो respond कर रहे हैं ना यहाँ.
Ma'am Vishakha.
And from this I can have an idea about who people are responding and who are not. So please be very attentive, especially in the practice, because all these things are going to be reflected in your final marks also. But this is for all of you, all these students who are present here. Okay. हाँ बोलो विशाखा.
So, ma'am, molecule lying inside the liquid is surrounded by the other molecules. So, it is attracted equally in all the directions. So, the net force of attraction acting on the molecule is zero. So, but however, the molecule which is lying at the surface, it is attracted by the molecules more than lying in the bulk of the liquid. So, so the molecule lying at the surface experience a net inward attraction. So as a result of this inward pull on all the molecules which is lying at the surface, so surface behaves like as it were in under the tension. That is like a stretch membrane. So because of which surface.
Hello. Hello. You're not audible now. Bacha, can you hear my voice? Can
Yes,
you hear me,
ma'am.
all of you? हाँ. ठीक है. She
Yes,
has
ma'am.
explained a little. She has explained to a great extent. So how surface tension is different from interfacial tension is, in case of surface tension, you have on the surface you have the water molecules. Suppose if we consider surface tension of water especially, right? You have water molecules on the surface. On one side you have air molecules, right? So there is competition. So यहाँ पर competition जो है, it is between the force of interaction between two water molecules on one side and a water molecule and an air molecule on the other side. जो कि the force of interaction between two water molecules will always be greater than the force of interaction between a water molecule and in an air molecule. इसलिए जो net pull जो है, it is towards the inner side. So this is the origin of surface tension. What happens in interfacial tension is, यहाँ पर suppose if we have एक beaker है suppose, ठीक है, और नीचे का पार्ट जो है, suppose it is oil. It is difficult to write here, but this is oil. On this side, suppose this is water. This is water. ठीक है. Suppose we have a molecule of oil here. One molecule of oil here. ठीक है. So on this side, it will be experiencing force of attraction between two oil molecules. ये एक दूसरे oil molecule है, another oil molecule is there, another oil molecule is there. On another side, you have it will face force of interaction between water molecules. So these are water molecules. ठीक है. So obviously यहाँ पे भी the force interaction between two like molecules, between two oil molecule will always be greater than the force interaction between an oil molecule and a water molecule. Is this okay बच्चे? So that's why it will experience a net inward pull. But यहाँ पे जो surface tension जो develop हो रही है, that will be different from the surface tension which would have been developed when we have air molecules here instead of water. Or if we have water, ठीक, oil ऊपर होना चाहिए actually. The diagram which they should be, oil should be upward and the water should be downwards. So can you feel the difference here? The interfacial tension therefore will be less here that would happen in case of surface tension of water alone. ठीक है, is this okay? So this type on the surface of a liquid when you have air on one side. Hello. Hello.
Ma'am, your voice broke between.
एक second. I have to see some. अब लोग थोड़ी देर रुक जाओ, right? Can you hear me now? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Sorry for the inconvenience. Now the drawing is also gone, right? ठीक है, so interfacial tension, I don't know how much you have, how much of my explanation you people were able to hear. Do I need to explain again surface interfacial tension ka, or shall we move ahead?
Ma'am, explain.
Explain करूं? Could you see the
Yes,
diagram that
ma'am.
I drew in before?
Yes, ma'am.
So in that, what I was trying to show that when we have um, a liquid molecule on one side and gas molecule on the other side, that the surface tension that develops on the surface of water is called surface tension, right? And when we have water on one side and other immiscible liquid like grease or oil on the other side, the surface tension that develop on either grease or on water, that is known as interfacial tension. Interfacial in the sense that it is the tension that develops on the interface, on the molecules which are present on the interface of the two liquids. Is it okay? And the formula of how to find out how to calculate the interfacial tension and all you will study in theory class. Okay? But what is the role of this interfacial tension in our today's experiment when we want to study the variation of surface tension with detergent, right? So these substances, that is the surfactants, they act as detergent and they have the characteristics of lowering the interfacial tension. This is very important. The surfactants जो है, their role is to lower the surface tension or lowered interfacial tension between water and grease molecules and thus render wetting of the latter easier. So what do I mean by this? This is the most important line. When we add some, so suppose when you have a mixture of water and grease, mixture of water and grease का सबसे simplest example is when your dirty cloths में क्या है कि grease particles are there on your dirty cloths and dust particles get stuck on your grease, right? So this is what you mean by dirty clothes. So that's why when we want to wash this without detergent, what happens? You have a mixture of water and grease. Okay, so that's why an interfacial tension get developed between water and grease. Is this okay, बच्चे? यहाँ तक clear है? If you have to see from the practical point of view, when you want to wash your clothes without if you don't have if you haven't put detergents in there, you have a mixture of water and grease. Grease कहाँ से? Grease from your dirty clothes. ठीक है? So an interfacial tension developed between water and grease. Mix नहीं होंगे दोनों. Those are two immiscible liquids. ठीक है? But once you add detergents, what will happen? Because of the peculiar property of detergents, which I have explained above also, it plays a role in decreasing the surface tension and all. So it will lower the interfacial tension between water and grease. जब interfacial tension develop करेंगे, when it decreases the interfacial tension, what will happen? It will lead to wetting of the latter easier. दोनों को mix up होने में it will play a role. It will help in mixing of the grease and oil particles. So mechanism of how it plays in mixing, how it helps in mixing of the two liquids, we will come in the later slides. Is this okay? So this helps in easier cleaning of our garments. Bache, is this okay? Fine. Can we go to the next slide?
Yes, ma'am.
Yes, ma'am.
I think soap action, cleansing action of soaps and all, you must be having enough idea about in micelle formation and all. So this is related to that only, because detergent is also some kind of soap, right? So cleansing now is cleansing action of soap and detergent. So how detergents or soap play a role in cleansing our dirty clothes, right? So first line में देखो, the red one, most of the dust or dirt sticks onto grease or oily material which gather on the cloths, right? So grease is not easily wetted by water, as गलती से लिखा हुआ है, and becomes difficult to clean a garment with water alone. We cannot wash a dirty clothes with water alone without putting any soap or detergent, right? Because grease doesn't mix with water. जब mix ही नहीं करेंगे तो उसमें जो dirt particles है वो हम कैसे निकालेंगे, right? So we have to have an intermediate thing which will play a role in mixing grease and your water. So once वो दोनों mix हो जाएंगे, then your dirt particles will get detached or will be separated from your grease and we can remove it with water itself, right? So in the presence of soap, third line देखो, the interfacial tension between water and grease decreases, resulting to easy mixing of two. यहाँ पर भी द लिखा हुआ है गलती से, ठीक है? So now coming to why, how, किसी का mic on है, please switch it off. Reason for decrease in surface tension, how these surfactants help in reducing the surface tension, ठीक है? So when higher concentration of soap molecules accumulated at the surface में क्या है? Because of the property of these surface active substances, higher concentration of soap molecules, or we can say surfactant molecules, will be accumulated at the surface, and These surfactants have a specific orientation. The molecules of the surfactants have very specific orientation. ठीक है. So the carboxylic groups, the COO groups जो है, these are known as the hydrophilic head also. They point towards the surface of water because hydrophilic का मतलब है कि water loving. So that's why they will have greater affinity towards water. So they will point towards water, which is also called the head. And the hydrocarbon chains, which are known as the hydrophobic tail. And all of you know hydrocarbons do not mix easily with water, and that's why they are known as hydrophobic also, water hating part. Hydro means water, phobic means hate, you can say. Water hating part or the tail part, which are the hydrocarbon chains, they will point outwards. Okay. So the hydrocarbon chains act as a solvent. So that's why what will happen, the hydrophilic head जो है, it will point towards water, and the hydrophobic tail जो है, it will point towards the grease particles. ठीक है. Grease जो है, these are organic parts, and they will mix up well with the hydrophobic part of the surfactant. ठीक है. So the hydrocarbon chains act as solvent for the grease particles, which get dissolved into the hydrocarbon chain and thus remove the grease from the cloth along with dust. ठीक है. So ये last वाली line जो है, this is how grease particles get detached from the clothes, and along with the grease we can remove the dust and dirt particles also, right? So ये लोग आप लिख लो, या फिर I'll give you handouts later on also, just understanding the class. ठीक है. मैं slide change करूँ?
Yes.
Now what is the term which is known as critical micelle concentration? Okay, when does micelle formation start? Right. So when you have a very dilute solution of your surfactant, इसका मतलब क्या है कि if you add a very small amount of detergent into water for washing your clothes, so what will happen? एक डायग्राम है, इसको दिखाती हूँ मैं आपको. ठीक है. सो प्रोसेस टुवर्ड्स माइसेलाइजेशन, ऐसा नहीं है कि आपका माइसेल फॉर्मेशन जो है वो शुरू से स्टार्ट होगा. इट विल फॉर्म एट आफ्टर अ पर्टिकुलर कॉन्सेंट्रेशन ऑफ योर डिटर्जेंट ओनली. ठीक है. तो फर्स्ट में देखो, द फर्स्ट पिक्चर, ये हियर इट इज एयर मॉलिक्यूल, यहाँ पर नीचे जो है वाटर है. तो एक्सट्रीमली डाइल्यूट सोल्यूशन दिया है. सो व्हेन यू हैव वेरी एक्सट्रीमली डाइल्यूट सोल्यूशन, some of the surfactant molecules are present on the surface, some are present on the in the bulk. ठीक है. But most of them will be present on the surface. So now उसके बाद थोड़ा सा आपने और डिटर्जेंट डाला, you are moving from very extremely dilute solution to a little dilute solution. उसमें कई सारे surfactant molecule जो है, it will be present on the surface. उसके बाद देखो, at this particular concentration, there is a 1 to the third picture. At this particular concentration, all the surface of the liquid, all the water surface are being occupied by the surfactant molecules. उसके बाद जो बचा हुआ surfactant molecule जो है, they will start forming micelle. तो micelle का structure, तो you must be familiar with the micelle structure. This is the, जो नीचे मैंने दिखाया है, this is the hydrophilic head, sodium ions part जो है, and ये जो है, this is the hydrophobic end, tail, hydrophilic head, hydrophilic tail. ठीक है. तो बीच में जो है, these are the grease or oil droplets. ठीक है. So what I can say is, only after a particular concentration of detergent, only when all the surface molecules are being covered by your surfactant molecules, then only micellization or micelle formation will start. So once the micelle formation start, ऊपर surface में there is no space for the surfactant molecule. जो भी आप surfactant add करोगे, it will lead to micelle formation. ठीक है. So यहाँ तक, from figure 1 to figure 2, as you keep on adding detergent solution, as you keep on adding surfactant solution, it will lead to a gradual decrease in the surface tension. यहाँ तक surface tension आपकी कम होती जाएगी, आप लोग जब आप concentration बढ़ाओगे detergent का. But once the micelle formation starts, there will be no more decrease in your surface tension. Surface tension value जो है आपका, it will give you a constant value after the micelle formation starts. So that's why from this we can have an idea, we can calculate and determine what actually is the concentration at which your micelle formation starts. And this concentration is known as your critical micelle concentration, CMC. And critical micelle concentration is a very important property of any detergent. Okay, so let's go back to our slide again. देखो, critical micelle concentration is defined as the concentration of surfactants above which micelles form, and all additional surfactants added to the system will now lead to micelle formation. Micelle critical micelle concentration के बाद जो भी आप detergent या surfactant add करोगे, it will lead to formation of micelles. No more surfactant will go into the surface. ठीक है बच्चे? Clear about CMC?
Yes, ma'am. Yes, ma'am.
So the CMC is a very important characteristic or property of a surfactant. ठीक है? So higher the CMC, the better is the detergent, you can say. Okay, so before reaching the CMC, this is I think just explanation of the figures, the picture which I just showed you. Before reaching the CMC, the surface tension changes strongly with the concentration of the surfactant. I've explained earlier also. And after reaching the CMC, the surface tension remains relatively constant or changes with a lower slope. Okay, I'll show you the graph also, the sample graph. The value of the CMC of a given dispersant or surfactant in a given medium depends on temperature, pressure, and sometimes strongly on the presence and concentration of other surface active substances and electrolytes. Abhi, don't pay much attention to this because and micelles only form above critical micelle temperature. Okay? And for example, देखो मैंने बताया ना CMC is an important characteristic of a surfactant. इसका मतलब है कि हर एक surfactant, every surfactant will have a different value of CMC. ठीक है? So ये sodium dodecyl sulfate जो है, it is a very common surfactant and इसका CMC जो है at 25 degrees Celsius and atmospheric pressure, this value is 8 into 10 to the minus 3 moles per liter. ठीक है? So I'm just giving an example to justify that CMC is an important characteristic of a surfactant, and it depends on temperature also, it depends on pressure also, right? ठीक है बच्चे? लिख लिया आप लोगों ने इसको?
Yes, ma'am.
So this is a 3D picture of how a micelle forms. क्योंकि यहाँ पे जो दिखाया था 2D picture है, 3D picture, it looks like this when a micelle forms exactly. ठीक है? So these are जो अलग अलग pieces दिखा रही हूँ मैं, ये these are the surfactant molecules, and this is when the two spheres are when they form micelle, right? So in actual they must be looking like this, the micelles. So how you're going to actually perform the experiment, performing the experiment is similar to what you did in the last class. कि last class में I told you, I explained you the procedure about कि एक unknown solution दिया गया आपको, कोई भी unknown solution, तो how to determine the surface tension. तो इसमें क्या है कि you will be given different concentrations of detergent solution. Starting from point, you will be given very dilute solution of detergent solution. One problem with detergent solution while you're performing the surface tension experiment is detergent solution जो है they give lot of ladder. ठीक है? तो झाग बहुत बहुत ज़्यादा झाग बन जाता है, and when you have to make the solution you have to shake them also. तो जब shake करते हैं तो इतना झाग निकलता है कि it creates problem in performing your experiment because you have to suck it into the stylogometer, फिर उसके बाद दोबारा से rubber pipe के through suck करना, and also in that case a lot of ladder or froth develops. ठीक है? So you have to take lot of care while you're performing this experiment in the lab. So that's why we try our level best to give you very dilute solution. But even though you're given very dilute solution, it will uh, create lots of difference. It will create lots of decrease in your surface tension value. So it doesn't matter, right? So what you will do is सबसे dilute solution से start करेंगे आप लोग concentration का. First you will start with distilled water. फिर उसके बाद you will start with the most dilute detergent solution. उसका time of flow निकालेंगे. The same thing you did. 3-4 readings लेंगे and the time of number of drops देखना है आप लोगों ने, right? And the number of drops should be almost, you should get almost 3 constant number of drop reading for one concentration of detergent solution. ठीक है? So now if you are done with the first solution, then उसके बाद second detergent solution start करेंगे. उसका भी आप number of drops count करेंगे, right? 3 बार number of drops concordant reading आनी चाहिए. Like this you have to repeat the whole procedure. जितने भी आपको concentration detergent solution दिया गया, so 5 6 जो भी दिया गया, उन सब का number of drop values निकालनी है, right? और यहाँ पे भी we will not determine the this thing, the density आप लोग निकालेंगे नहीं, just number of drops निकालेंगे, right? तो उसके बाद हर एक concentration detergent solution का आप surface tension value calculate करेंगे using the formula I provided in the last class. ठीक है? Gamma 1 upon gamma 2 is equal to D1 T2 upon D2 T1. I think this is the formula. इसको use करके आप surface tension हर एक detergent solution का निकालेंगे, right? So now finally what you will do is you will see कि how is the variation of surface tension with the concentration of detergent. तो उसके लिए आप लोग ऐसा graph plot करेंगे, right? So x-axis में you will take concentration. जो भी आपको concentration दिया जाएगा detergent solution का, maybe in terms of percentage या molar जो भी है, उसका corresponding unit लिखेंगे x-axis में. y-axis में surface tension, जिस water का जो भी unit दिया जाएगा आप लोगों को surface tension का, you'll have to write in the same unit like that of water. ठीक है? फिर उसके बाद you will see कि ग्राफ कैसा आ रहा है. यहाँ पर 3 सर्फेक्टेंट्स का कंपेयर करके दिखाया है, just a sample graph which I took from Google images only. ठीक है? You just have to plot just one graph only because you'll be provided with just one specific detergent. ठीक है? So what you will see is you will see a gradual decrease from one portion to another because you're plotting concentration versus detergent. फिर उसके बाद a particular concentration के बाद you will see that your graph is showing a horizontal line. Not even exactly horizontal, the value जो है that will be decreasing very slowly. तो इसका मतलब ये है कि यहाँ पर देखो जहाँ से आपको horizontal line show करना start हो रहा है, that is your critical miscelle concentration. Why critical miscelle concentration? क्योंकि यहाँ पर आपका miscelle formation start हो गया है और जो भी आप सर्फेक्टेंट या डिटर्जेंट ऐड कर रहे हो वो सरफेस पे आप उसको उसके प्रेजेंस का कोई मतलब देयर इज नो स्पेस अवेलेबल ऑन द सरफेस द लिक्विड फॉर द सर्फेक्टेंट. सो इसलिए जो भी आप ऐड कर रहे हो it will be in the form of miscelle from ठीक है. So that's why there will be no further decrease in the surface tension. So that's why you can see a horizontal line or constant value of surface tension after the CMC. So this is what you call the CMC. This concentration corresponding is what you call the CMC. So this you have to report in your result. ठीक है बच्चे, is this okay? Any doubt? So you will be provided with all the values, all the data, and you can see, you can check from that only ki how the surface tension values are changing, what is the CMC and all. So do you have any rough idea about how you will perform the experiment, how you'll plot the graph and all? Please pick up.
Ma'am, we will use count number method.
Drop number method only, yes.
Sorry, ma'am, drop number method.
Mm-hmm.
Firstly, we measure the density of the liquid, all the solution which will be provided to us.
Density इसमें measure नहीं करेंगे. You will be provided with very dilute solution. तो I don't think इसमें density measure करेंगे. एक बार मुझे ना
सेम रहेगी लगभग.
एक सेकेंड रुक जाओ. Let me check the file which I have. I think इसमें we don't let the student measure the density because it is a huge task. to determine the number of drops for all the 5 or 6 solutions given. तो उसमें time नहीं मिलता बच्चों को. But let me just check, okay? Because I have to tell you according to the data I have, otherwise you people will complain me कि no, you will not measure the density here, just like you did in the last case, in case of viscosity. Right, density will be taken equal to that of 1, so cancel हो जाएगा. ठीक है? But in some of the cases it may be like here, for example, in the file which I've been considering, in some of the cases you are not able to determine the exact surface tension because the exact CMC, because CMC जब तक हमें CMC मिलता the solution becomes so thick, इतना ज़्यादा ladder बन जाता है उसमें कि we're not able to find out the exact surface tension of the critical micelle concentration even. ठीक है, so उतना concentration तक हम दे नहीं पाते students को. तो in this particular file itself we are not able, she is not able to find out the CMC क्योंकि वो horizontal position आ नहीं रहा है इसमें भी, horizontal part. ठीक है, कोई बात नहीं, if it doesn't come it's fine. Where the horizontal portion starts, that is called CMC. If it doesn't come, it's fine. ठीक है? So anything else you want to ask? Hear properly what you were asking.
Hello, ma'am.
हाँ बोलो. Is it Shushti?
No, ma'am, Sanjana here.
संजना. बोलो.
मैम ऐसी कोई मतलब कंसंट्रेशन है जहाँ पर जो मिसेल फॉर्मेशन है वो स्टॉप हो जाएगी, उसके आगे होगी ही नहीं.
ऐसा concentration जहाँ पर मिसल फॉर्मेशन स्टॉप हो जाएगी, मतलब मिसल फॉर्मेशन तो एक
Mean-
पर्टिकुलर concentration के बाद स्टार्ट होती है, उससे पहले कोई मिसल फॉर्मेशन स्टार्ट नहीं होती. जब डाइल्यूट सॉल्यूशन लोगे तो you won't have any micelle formation, right? So when your detergent solution becomes concentrated, then only micelle formation starts. So what is your question exactly?
Ma'am, I was asking कि
Yes, I'm hearing.
कि जैसे हम जो मतलब डिटर्जेंट या सोप.
Again your voice is not coming, Sanjana. Hello. Hello. Bacha, can you hear her voice, all of you?
Yes, ma'am.
No, ma'am.
No,
Okay,
ma'am.
संजना दोबारा से बोलो. Your voice is मतलब is not audible at all. Hello. Hello. संजना, you speak up.
मैम आवाज आ रही है?
अब आ रही है अब. Now it's coming.
जब हम डिटर्जेंट डालेंगे उसमें जो हमारा लिक्विड होगा.
फिर से चलेगी तेरी आवाज.
हेलो.
Yes, अब बोलो.
डालेंगे तब एक कंसंट्रेशन पे हमारे
कौन अगेन? तब एक कंसंट्रेशन पे के बाद बोलो. Hello. I don't know whether the internet connection problem is from my side or your side. Cannot hear you. And it always happens at the end of the class only after 1 hour or so. Bache, can you hear her? If somebody has heard her question, you can explain to me. Hello?
Hello, ma'am.
Sanjana, your voice I cannot hear at all.
Connection problem हो रही है यहाँ
आप
पे
बाद
शायद.
में पूछ लेना मेरे से. You just call me after the class. ठीक है, normal call या WhatsApp call. Anybody else who has any query? Anybody else who does have any doubt, who needs some clarification or anything? आ गया सबको समझ में? Each one of you has understood everything? I told you we have to continue with the Viva also. From again next week, I'm going to keep the Viva. Maybe we may not continue further with a different experiment. Okay? So next week, I will try to take Viva of almost 10-15 students. So come prepared for that. Anything else you want to ask regarding this experiment?
एक्सक्यूज मी मैम.
Yes, बोलो.
मैम ये जो हम एक्सपेरिमेंट कर रहे हैं सब टॉप क्वार्टर में है ना?